Okay, page 39. So there's the three laws of logarithms that we used, or that we saw yesterday, and we did use them to help us simplify some expressions involving logarithms. We saw that as long as the bases were the same, we could combine terms using these laws. If terms are added together, logs with the same base, we can use the product law to write them as one term. If terms are subtracted, logs with the same base are subtracted, we can use the quotient law to write them as a single logarithm. And then the power law as well, we use in some cases to help us simplify expressions involving logs with the same base. So we'll continue to use these today. In this case, we're going to work the other way though, where we're going to expand. It says write each expression in terms of individual logarithms of x, y, and z. So in this case here, the log is with a base of 5, so when we expand these out, all logarithms will have to be base 5 as well. On top, it's x times y, which will be log base 5 of x plus log base 5 of y. When you're multiplying things together in the argument, we use the product law, which is the sum of the individual logs. And because you're dividing by z at the end, that's the quotient law. You're going to subtract log base 5 of z. Okay. For question B, we know that cube root means power 1/3. And then the exponent can come in front as a coefficient. And now we've written it in terms of log base 7 of x. For question C, I would first bring the x squared from the bottom to the top, which will make it x to the negative 2. And then again, the exponent can come in front as a coefficient. And we've written that one in terms of log x. Now for question D, because you have two factors on the bottom, I'm going to put those two parts in brackets. So it'll be log of y, and because y is multiplied by the root of z, we use the product law. So it'll look like that. So the 3 on the x, the exponent 3 can come in front as a coefficient. A minus sign in front of the bracket changes all the signs inside. So they'll both become negative. And square root of z is same as z to the 1/2. So our last step was we'll bring the exponent 1/2 in the last term in front as a coefficient. And there's the expression, written in terms of log x, log y, and log z, which is what we're asked to do. But it's important in that first step that you group those last two terms together to keep them all part of the denominator. And so we'll do the same thing for these ones, write them in terms of log x, log y, and log z. The first one, because the argument is a quotient, we'll use the quotient law, which is the difference between the two individual logs. Now for question B, both the x and the y are raised to the power 1/2. So I first wrote it like that, and because those two are multiplied together, it'll be log base 5 of x to the 1/2 plus log base 5 of y to the 1/2. The exponents can come in front as coefficients. And there is one step that we can do which simplifies it a little bit, and that is taking out a common factor of 1/2. Not necessarily required, but it does simplify it a little bit. Right? Question C. Because the argument is a quotient, we can use the quotient law and say that's minus log base 3 of x, and the cube root of x squared is x to the power 2/3. So there's a couple things we can do here. Number one, log base 3 of 9, well, that's 2. That's asking 3 to what power is 9. And for the second term, the exponent comes in front as a coefficient. So there, that one is written in simplest form. Question D. The numerator of the argument is a product, so we'll use the product law. And this is base 7. And the denominator is just the root of z, which is z to the half. And then we have two terms with exponents. They come in front as coefficients. So again, it's important to remember that these laws can be used in both directions. You can use them to combine terms into one single term, but you can also use the law to expand. And so one of the uses of these laws, as we saw yesterday, is that you can combine terms, and in some cases, the individual logs, if you evaluate them, will be irrational. But when you use the law of logs, you'll get an argument that you can evaluate without even using a calculator in some cases that we saw. So because these logs all have the same base of 6, we can use the laws of logs. On top, we're going to have 8 times 9 because that's the sum of those two logs. And on the bottom, we'll have our 2 because you're subtracting log base 6 of 2. 8 times 9 is 72, divided by 6 is 36. We've seen this one a couple times already. This means 6 to what power is 36? Well, the answer is 2. And we saw yesterday that we can use our calculator to check, put our original expression in. Log base 6 of 8, which would be irrational on its own, plus log base 6 of 9, which on its own would be irrational, minus log base 6 of 2. So our answer checks. So this is certainly a common application of these logarithm laws. Question B, that'll be log base 7 of 7 plus log base 7 of 7 to the power a half. Log base 7 of 7 is 1. That's asking 7 to what power is 7? Another way of looking at it is if you use the change of base identity, it'd be log 7 divided by log 7. Dividing something by itself will give you 1. For that second term, the exponent comes in front as a coefficient, and once again, log base 7 of 7 is 1. It will be 1 plus half of 1. 1 plus a half will be 1.5 or 3 halves. Right, question C. Again, we're simplifying. We're writing them as a single log first and then evaluating. So for the first term, the 2 can come up as a coefficient. It'll be 12 squared or 144 minus So let's keep the brackets for now. Let's see if we can simplify that expression inside the bracket. For that second term in the bracket, coefficient of 1/3 again comes up as an exponent. And power 1/3 means cube root. And the cube root of 27 is 3. And now inside the brackets there, we're adding logs with the same base. We can use the product law to combine those into one log. It'll be log base 2 of 6 times 3, which is 18. And now we've removed the brackets because we only have a single term left there. And we can now combine that expression into a single term. Because we're subtracting logs with the same base, we can use the quotient law. So it'll be log base 2 of 144 over 18. And 144 divided by 18 gives us 8. So log base 2 of 8 will be 3, because that's asking 2 to what power is 8. And once again, if you wanted to, you could put this entire expression in your calculator and check it. 2 times log base 2 of 12, which on its own will be irrational, minus, open a bracket, log base 2 of 6, plus, in brackets, 1 over 3, there's my coefficient of a third, log base 2 of 27. And we get our answer of 3. So it checks. So we'll do much the same for these next ones. Use the laws of logarithms to simplify and evaluate each expression. So this is an example of where we would expand. Log base 3 of 9, and because the 9 and the root 3 are multiplied together, that's our product law. It'll be plus log base 3 of 3 to the 1/2, because that's what square root means, power a half. Log base 3 of 9 will be 2. That's asking 3 to what power is 9, plus 1/2 log base 3 of 3, right? The exponent comes in front as a coefficient. So we'll get 2 plus a half, or 2.5. As a rational number, that'd be 5/2. Right, for question B, we saw ones like this yesterday where we would introduce brackets. And a minus sign in front of the bracket changes all the signs inside, so they will both become positive logs, which allows us to combine those ones inside the bracket using the product law. It'll be log base 5 of 4 times 2, which is 8. And now because we're subtracting logs with the same base, we can use the quotient law. And 1,000 divided by 8, I think, is 125. Yep. So this will be log base 5 of 125, which is 3. Because that's asking 5 to what power is 125. But you could do that on your calculator. If you don't have the newer operating system, use a change of base. Log of 125, close the bracket, divided by log 5. Gives you your answer that way as well. All right, question C. We've seen ones like this before where we rearrange the terms. Put the positive ones together first. At the same time, I'll use the power law to bring any exponents up as coefficients. Any coefficients up as exponents. So it'll be log base 3 of 6 squared. Again, I'll put the plus positive terms first, followed by the minus term, which again, the coefficient of 1/2 comes up as an exponent. So this will give us log base 3 of 36 plus log base 3 of 2 minus log base 3 of 8, because power 1/2 means square root. The root of 64 is 8. And now we can use the laws of logarithms to combine this into a single logarithm. Because the first two are added together, that's our product law. Last term is subtracted, that's our quotient law. So 36 times 2 is 72, divided by 8 is 9. This will be log base 3 of 9, which is 2. That's asking 3 to what power is 9. And as we've seen, you can check any of these by using your calculator, because the arguments are all numbers. But when the arguments are variables, not quite as easy to check them. You could still, by just assigning any arbitrary value for x. You could look at x equal any number greater than 0, because remember, you can't take the log of a negative number, nor can you take the log of 0. But in this case here, I can combine those first two terms together. It'll be x squared times x minus. So the way you look at that last term, that would be the same as 5/2 log base 7 of x. The first term, when you simplify, becomes x cubed. And that last term, you write the coefficient up as an exponent. Because our next step now, we're subtracting individual logs with the same base, we can use the quotient law to combine them. And now you're dividing powers with the same base. So you subtract the exponents and keep the base the same. You're going to go 3, take away 5/2. We need a common denominator. 3 would be 6/2, minus 5/2 is 1/2. And we could take the 1/2 in front if we wanted to. Would look like that. Now this also says state restrictions on the variable. Remember, you can't take the log of 0, nor can you take the log of a negative number. So in this case, x has to be greater than 0. We have 3 arguments. They're all either x or x squared. So x can't equal 0, nor can it be negative. So there's our restriction. So these next ones are a little bit different, because the arguments are polynomials. We're still going to use the laws of logarithms, though. It'll be log base 5 of 2x minus 2 over x squared plus 2x minus 3. Again, because the bases are the same, we can combine them. But this can be simplified, because you can factor. The numerator has a common factor of 2, and the denominator is a trinomial. The factors there would be x plus 3, x minus 1. And this allows us to simplify, because you can divide top and bottom by a factor of x minus 1. So that would be the final simplified answer. Now, for the restrictions, look at the arguments, and we need to look at the factored form of the arguments. That's what's really going to help us get our restrictions here. So we have factors here of x minus 1. So for that specific factor, x would have to be greater than 1. Because remember, you can't take the log of 0 nor a negative number. So if x equals 1 on top, you'd have the log of 2 times 0. which is 0, and then 0 divided by anything also gives you 0. Can't have that. And also, x can't be negative, or I should say, x can't be something less than 1, because if you let x equal 0, once again on top, you have the log of a negative number. And it goes back to this first term. Right? If x is 0, you'd have the log of a negative number. Can't have that. But we also have factors on the bottom of x plus 3, which means x has to be greater than negative 3. And then a third factor on the bottom is our x minus 1, which you've already addressed above. X has to be greater than 1. So we've got two conflicting statements here. We need to pick the one that satisfies them all, which will be that x is greater than 1. All numbers greater than 1 are also greater than negative 3. So there's the restrictions for that statement. Okay, so same thing for these ones. We use the laws of logarithms to write as a single log and then talk about the restrictions. So we can work inside the brackets there first. Because you're adding logs with the same base, we can use the product law. But what we should do first is take that second term and use the power law. Bring the coefficient up as an exponent. And then we can combine those two terms. It'll be log base 5 of x times x to the 5th. When you're multiplying powers with the same base, you add the exponents and keep the base the same. X to the 1 times x to the 5th is x to the 6th. So I can take that first term and bring the coefficient up as an exponent. So it'll be log base 3 of x to the 4th. Same thing with the last term. I'll have log base 3 of x to the 6th to the power 1/2. And when you have one exponent raised to another, you multiply the exponents. Six times 1/2 is 3. And now you're subtracting logs with the same base, so you use the quotient law. It'll be log base 3 of x to the 4th over x cubed, or log base 3 of x. Because when you're dividing powers, you subtract the exponents, keep the base the same. All of the arguments here are just x, so a restriction would be that x must be greater than 0. But for question B, the arguments are polynomials, so it's going to involve factoring, and then we have to look at each factor from the arguments so we can determine what the restrictions are. So I'm going to do two things simultaneously. I'm going to factor the arguments. That first one is a difference of squares, and as well use the quotient law because you're subtracting those logs. So it'll be x minus 3, x plus 2. The x minus 3's will cancel. And we have log base 2 of x plus 3 over x plus 2. So there's our simplified expression. But to get our restrictions, we have to look at each argument, the factors of each argument. We have a factor of x plus 3, so x must be greater than negative 3. We have a factor of x minus 3, so x has to be greater than positive 3. On the bottom, we also have a factor of x minus 3, which we've already dealt with, but we have a factor of x plus 2, so x must be greater than negative 2. Again, you have three conflicting statements, you need to choose the one that satisfies them all, which will be that x must be greater than 3. There's your restrictions. There have been questions like this on diploma exams. Describe the transformation or transformations that need to be applied to the graph of y equals log base 3 of x to result in the graphs of the following. So if we're talking about transformations, remember that's our 4 parameters. A, B, H, and K. Now we might not have all 4 parameters for these questions, but you're going to have at least one of them. So you have to write the expression in terms of, so that you have terms that look like that. Okay, Diego? So this is where we once again would use the laws of logarithms to expand. Because it's 243 divided by x, you can use the quotient law. And that becomes log base 3 of 243 minus log base 3 of x. Remember, we're always comparing it to y equals log base 3 of x. So we have a term that is log base 3 of x. But we also have that first term, log base 3 of 243. That's asking 3 to what power is 243? And I think it's 3 to the power 5 equaling 243. Yep. Because that's what that means. You could also use your calculator, use the change of base identity, or the log function if you have it to calculate what that is. But that is 5. And the only thing that we would do differently is just rearrange those terms to put the log part first and then the plus 5 second. So now we've written that in a format that we can talk about what transformations are happening. Compared to y equals log base 3 of x, you got that negative sign in front, which means there's going to be a reflection about the x-axis. And then because you have the plus 5 on the end, that's a k value of plus 5. That means it's going to shift 5 units up. So we need to do the same thing for part B. We need to expand it out. And because it's 9 times x squared, we would have log base 3 of 9 plus log base 3 of x squared. Log base 3 of 9, that's asking 3 to what power is 9? The answer is 2. For the second term, the exponent of 2 comes in front as a coefficient. So it'll look like that. And if we write it in the format that we're used to working with, we move that plus 2 to the end. So we have an A value of 2, so that means a vertical stretch about the x-axis by a factor of 2. Remember, the vertical stretch must always be written as about the x-axis. And then it's also going to shift 2 units up because you have a k value of plus 2. For this next one, you're told that the log of 2 is A, log of 7 is B. Write an algebraic expression in terms of A and B for each of the following. So again, there have been questions like this on diploma exams in the past. For question A, because it's 2 divided by 7, you use the quotient law. That'll be log 2 minus log 7. And we're told that log of 2 is A, log of 7 is B. So written in terms of A and B, that will be A minus B. So you need to write each of these parts, or each of these logs, in terms of log 2 and log 7. And then you can substitute in A for log 2, B for log 7. Question B, again, it's a product. So it'll be log 7 plus log of the root of 2. Log 7 is B. Before we can work with that second term, we have to have it in terms of just log 2, which we can do because the square root of 2 is the same as 2 to the half. The half comes in front as a coefficient, and now we can replace the log 2 with A. That expression will be B plus 1/2 A. Question C, well, it's not, we don't even see a 2 and a 7 there at all, but we can still do this because the 49 and the 16 are divided. That's the quotient law. That'll be log 49 minus log 16. And 49 can be written as 7 squared. So now we have log of 7. In the same way, 16 can be written as 2 to the 4th. So now we have log 2. But we have to bring the exponents in front as coefficients, so it's written exactly in terms of log 7 and log 2. And now we can substitute in B for log 7 and A for log 2. Now they're written in terms of A and B. So you can work on page 400 to 401, 2, 3, 5, 6, and 8. Remember that assignment from yesterday, that worksheet that's in your package was due for Mark. Most people got it done and handed in already. And get it handed in. Okay? So next, tomorrow we'll look at some problems involving logarithmic scales. And then I think we spend a couple days on 8.4. And then after that, we'll have a quiz on chapter 8 and our next unit exam, which will be on chapters 7 and 8. Okay?